Hello everyone, good day to all of you. Low strength pile integrity test is a simple, cost effective method to evaluate shaft integrity of concrete piles. These methods provide continuity of the pile, degree of defect and the location of defect. The method will not be able to provide any pile bearing capacity. Hi, I'm Parthasarathy, founder and managing director, Sarathi Geotech and Engineering Services Private Limited. We are technical partners of Pile Dynamics USA to represent them in this part of the world to provide training programs and tech support. Pit testing will record velocity time history up to the toe. For an idealized pile, the velocity will follow the x-axis until you find the toe response. If there is any serious defect like necking, there will be an early positive response in the velocity trace ahead of the toe. Therefore, it is important to identify if there is any reflection earlier than the toe to qualify the pile as good or bad. I will give you the 6 tips of conducting the pile integrity test. First, you need to have access to good pile top. Number 2, construction records is important information for conducting the pile integrity test. Number 3, access to geotechnical information. You need to have the equipment and sensors calibrated as per the codal provision. Depute trained and skilled manpower to the project site, and the interpretation should be performed by a qualified and a certified engineer and approved by an expert. So why all these are necessary and important? Pile top preparations. How do we do that and why is it necessary? When you are conducting a pit testing, you should ensure that the pile top surface is flat and smooth by removing all the contaminated concrete, the loose debris, muck, and only sound concrete should be present. You should have a flat surface. If required, grind the surface with a handheld grinder to arrive at a smooth finish and smooth surface. Then you grip the accelerometer, which is very sensitive, using a wax, Vaseline or a putty to get the bonding between the sensor and the pile top. Once the accelerometers are gripped to the pile top, using a handheld hammer, give an impact within 30 cm radius from the accelerometer. The pit testing will record the velocity time history. As long as the geometry of the pile is uniform, you will not have any early response from this velocity trace. If there is no early response in the velocity trace, we can conclude that the shaft integrity is good and you will only see the toe response. And therefore, the pile top preparation is very important to have good quality data, which is paramount for good interpretation of the results. The construction records, how is it useful? You will know from the construction record the length of the pile, the volume of the concrete that deep foundation element has consumed, and this information can go as an input. For example, you can put length as an input and arrive at the toe response by varying the wave speed. For concrete piles, the wave speed can vary between 3300 to 4300 meter per second. The volume of concrete will help to arrive at an impedance profile along the deep foundation element by what we know as a profile analysis. So construction record will always be an useful information while interpreting the results from the pit testing. Calibration of equipment and sensors. You have to get these equipments and sensors calibrated, A, to meet the codal provisions requirement. Number 2, you will have confidence on the quality of the data you are acquiring by inputting the right calibration constants. Number 3, you will not also embarrassed with the customers when they see that the equipment and sensors are not calibrated and they refuse to approve the test results. While conducting the pit test, one need to calibrate with different size of the hammer. Why is it important? When you have a short pile, if you use a big hammer, I think you will not have the toe response, and also the initial pulse width will be very large. Therefore, it is important to calibrate the short piles with a small hammer in order to not overlook the serious defects towards the pile top. In other words, the small hammers will have a sharp peak and a lesser pulse width, which also detects the defects towards the pile top. If you use a small hammer, the incoming pulse will not propagate because of the pile effects and the soil effects, and therefore you will not be able to locate the toe. In that sense, you have to use a bigger hammer in order to arrive at a toe response. So how to arrive at what size of hammer is necessary for that particular project site? How to choose a hammer? So multiple size of a hammer has to be used in a particular project site. Look for consistent blow, look for the toe response, and use that size of the hammer which gives you consistent blows and a toe response. We need to calibrate different size of the hammer in a project site, and once calibrated, use the same hammer for all the piles in the same location. Why is geotechnical information necessary while interpreting the pit results? The access to geotechnical information will reveal whether there is any anomaly in a particular location that can be corroborated with the results from the pit testing. For example, if you have a cohesion-less material within a cohesive formation, we all know that there could be some kind of caving in of the boreholes, and therefore there could be a larger volume of concrete consumed at that particular location. On the other hand, there could also be a soil cave in at that particular location, and thus the interpretation of the pit results, whether it's a necking or a reduction in the cross section or bulging with an enlargement of the cross section, can also be confirmed by the geotechnical information. So this is very useful. Deputing untrained and unskilled manpower to the project site will result in bad data acquisition and also will result in wrong interpretation of the results. The pit test results should be analyzed by a certified engineer. The reason is he will be able to identify consistency in the blow, what is good quality data, bad quality data, and during the data processing involves conditioning of the data to eliminate the pile effects and soil effects. So there are certain procedures which only an experienced and a trained engineer could perform the data processing, and therefore it is important that the data shall be analyzed by a trained and an experienced certified engineer. All the test results should be validated and approved by an expert. There are several limitations of this pit testing. To name a few of them, particularly two major limitations. One, the objective of pit testing is to identify major defects. If there are any defects below the first major defect, the pit testings cannot identify. Number two, there will be an uncertainty in location of the toe in the tune of about 5 to 10% because of the variation in the wave speed. And these are the two limitations. In order to overcome this limitation, there are other methods to perform the integrity evaluation, like your cross-hole sonic logging test. So I'll break down simple steps and procedures to conduct a CSL test in my next video. Stay tuned for more information. Until then, happy learning and thank you.